Like to see pictures, so I am going to let y'all see that. We're going to have a recap of active collaboration and the scoring rubric. Then we're going to go to the bell ringer and a debrief. I will collect your homework in a second, so you need to have that out, ready to turn in. And then we're going to go over lessons 2 and 3, understanding check. I'll pass that back out in a second. Before we do lesson 4, or finish up lesson 4 and the understanding check on lesson 4. So, it's good to be back. I am exhausted. I will go ahead and tell you. Waking up every.
It's because
I'm about to kick you out of my class. You're just being disrespectful at this point.
How? You just said you were exhausted. So what was you going to tell me? You could have got an extra.
The point is that I actually give a crap about your education. I give a crap more than some of y'all give a crap about your education, unfortunately. All right. Here is Alexander William Kinney. That's like in the hospital still, like just cleaned up. I figured I wouldn't show you all the super nasty picture of him. That's my wife and I with him wrapped up. That's close to us leaving the hospital. That's when we get home. My wife is all about the spooky month of October, so she's actually really excited that Alex was going to be born in October. So we got a little ghosty pajama set for him. And that's Alex looking absolutely adorable in my opinion. If he doesn't think he's adorable, you know. And then Sirius in the background just being the best boy ever. Just like Sirius Black, yep.
Harry Potter.
From Harry Potter. Yep, Sirius Black. Not like S-E-R, right? S-I-R-I-U-S. It's a British name, I guess, according to J.K. Rowling. And then there's me just like super content with Alex. I think I just fed him, which is why the bottle's there. Yeah, it's been good. It's definitely something completely different in my life. I definitely am getting way less sleep than I used to. Trying to help my wife take care of Alex throughout the time. All right. But it is time to get back to learning. I gotta say, I am a little frustrated just from some of the reports, especially from this class. I was over my third block where I had a couple of subs say, yeah, they just kind of did whatever, especially when I assigned literacy for all. And I'll go ahead and tell you this. Some of us need to follow directions better. I can see already from literacy for all that we didn't watch the videos to know the expectations for how I wanted you to do the outline and do the essay and things like that. And so I am going to score those somewhat harshly. I'm going to give you a chance to do a revise and resubmit though based on the feedback I give you. That's your choice. I gave you 2 days in class to work on it. And I know, especially in this class, some of us took advantage of that time and said, oh, well, it's not due till Monday. Literally, that was a quote that the sub gave me from several students. And so we just sat around and did nothing. Y'all gotta know, if I give you an assignment for 2 days, I'm expecting something good. Again, I'm gonna grade it, and I don't want you to say harshly, I'll say this, I'm gonna grade it fairly, like I'm not gonna be nice about it, I'm gonna be fair about it. But I'm gonna give you a chance to revise and resubmit. That's the way I'm gonna balance that, okay? Also, I've already started giving feedback on the test corrections. I'm going to give you all a chance to revise and resubmit those as well, because some of us missed the point of that assignment. The point was not to say, hey, I forgot to write an equation. If you didn't write an equation, then you needed to fix that and actually write the equation. You actually had to correct your mistakes. And this is not like the ACT test corrections where you can just bull crap by writing something down. Because yes, I went over those and looked at them as well. And I'm not stressed about the ACT math test corrections if you're a junior. That's a thing that we have to do, and you can write stuff down there. But the test corrections for my test, no, you got to learn that stuff. Hopefully I can stop being nasty, Mr. Kinney, and we can start having fun again. As much fun as we can have with algebra, right? I know. Yes, Madison.
I turned my what's it called? What's that essay thing called that we did the essay
Literacy
with?
for all?
No, the other thing. The y'all know what I'm talking about, where you do
No.
the paragraphs.
Annotations?
No, yes, the outline, sorry, I couldn't remember. I turned the outline in, like, on paper, and I turned the essay in on, Schoology, and then they gave me like a 0 or something on the Schoology thing. I don't know.
No, you got a 0 on Schoology probably for the talk assignment. I haven't given scores on that outlines or essays yet. Yes, Salita.
It wouldn't let me do that math.
2 weeks later, I'm just now hearing about it.
I just tried it.
That sounds like a problem when you're supposed to have multiple days in class to work on mathy stuff
When you gave us so much stuff,
that you did nothing of on days that I was gone for 2 weeks.
because we got other classes.
When you're in my class, do my classwork. There's no way you get attitudes about it. You didn't do any of it. That ain't my fault. Yes, Elijah.
On math, okay. It's not good. Why we didn't like learn the stuff that you assigned on math year before? I don't know how to say it. Like the stuff on math year, some of it we didn't even learn yet. We learned how to do it after we did the math year assignment. Why we couldn't learn how to do it first and then do the math year assignment to where we understood it. It can go ahead and get it finished and not struggle on it.
I have no clue what you're referring to that you learned after you did it on mathy.
We did the little square thingamajig where we multiplied and stuff. That was on Matthew. We didn't learn about that until earlier.
You didn't have that on mathy.
Yes, we did because I had it. He said he had it.
You weren't supposed to if you went to the right class assignments. There was no point where you were supposed to be distributing.
It went on. That went on thing.
Okay, I mean, you can get all frustrated about it, but that wasn't an assignment that I gave you.
Okay.
So, the only thing I assigned that we hadn't covered in class was the stuff on domain range, x-intercepts, y-intercepts, which we covered some of that stuff. But that was a review from Algebra 1, and it wasn't designed to be a struggle. Mathia gives you support and teaches you if you are using the supports that they have in there to be successful. But also, I wasn't here to teach. I did the best that I could. Sorry. All right, active collaboration rubric. A lot of us need a recap and reminder of what I'm expecting in terms of active collaboration, I would assume, because probably out of practice of it, just like we're out of practice of putting the phones up and reminding each other, reminding ourselves that you are in fact capable and not capable of getting an attitude, but capable of growing and learning and improving our understandings. So, at the end of the day, what are the things I'm looking for in whole class discussion? When I'm at the front of the board, asking questions, trying to engage y'all, what am I looking for?
Collaboration.
Say again?
Collaboration.
Collaboration. What does that mean in whole class discussion?
Talking.
Okay, what kind of talking? And I need y'all to remember, I'm talking about whole class discussion, not small group.
Sharing ideas.
Okay, so sharing your ideas, right? What thing, and I want y'all to remember, like, this is not just on you. Most of the time when we have a whole class discussion, I've let y'all talk in small groups first, right? Right? And so, you need to share ideas, yes, but they aren't just on you. They're the ideas that you and your group have developed, right? So there should be no super high burden to feel like you have to be the smartest in the room or you have to be perfect. Like, you have support in the terms of the small group to talk with each other and grow and to learn. Hey, Anthony, why is your book not out, dude? For those of us who still have our books closed, what page are we supposed to be on right now?
167.
167. Please turn to page 167 in your book. Okay? So, you're supposed to share ideas. What else are you supposed to do during whole class discussion?
Questions about something you don't understand.
And I will point this out, it doesn't just have to be questions about stuff that you don't understand, but literally part of your burden as a student, which is a weird word to use now I'm thinking about it, but part of your job as a student is to ask questions. Learning means that you don't already know the answers. And a lot of us get frustrated and get down because we're like, oh, I don't know the answer. Then ask a question. Or, and I will praise Hudson on this a lot for sure, because I think he does a great job of this. Hudson starts trying to put things together and ask questions about, well, how can this apply here, and starts thinking beyond just what we're talking about sometimes. And others do that as well. Kaya's done that for sure. Gabby's done that. But ask questions. When you are engaging your brain, one, the math and the learning is more fun and more interesting, and you're more invested. But ask all the questions. Ask questions if you're not sure about something. Ask questions if you're like, hey, I wonder how this could apply here. Ask all the questions. It's going to help you grow and to learn. Literally, that is a huge part of your growth as a student. All right, so sharing your thoughts, asking questions, what else? There's one last thing in whole class discussion. I mean, y'all are looking at me when it's literally on the board. I mean, yeah, you need to pay attention. That's necessary to share ideas and to ask questions. There's a third major thing. You gotta take notes. Ladies and gentlemen, like I know taking notes is not sexy, but at the same time, you gotta take notes so that you have effective resources to go back and use on homework assignments, to study, to make flashcards out of, to do whatever you need to do to help you study, right? I know a lot of us are like, oh, I learned it best this way. Cool. Then make study resources that help you study that way, right? If you know you're good with flashcards, make flashcards. I'm going to make sure that I go over the content and the ideas that you need to be aware of. Take those notes so that you can go back to them and study them. I personally am a person who just, when I study, I just read back through the book and I make sure that I understand the concepts and do a couple practice problems. That's how I study. Other people need flashcards. Other people need to rewrite their notes. Other people need to talk it out with somebody else. Like, I don't know what is your best strategy, but take notes so that you can apply it there. Finally, in small group, this is what Emma was referring to earlier, collaboration. But what does that really mean, collaboration in small groups? What do you need to be doing?
Talking to you.
Okay, you got to be talking to your groups, but I want to push on that a little bit because I feel like this is something that some of us are misunderstanding. When I say talking with your groups, what does that really mean? Does that mean talking at somebody and just sharing your ideas?
But also listening.
But also listening? Just like in a whole class discussion, I always ask the question, does anybody have a question about that, or does anybody want to push back on that? Do the same thing in your small groups. Which means you're going to have to listen when somebody else talks so that you can ask questions or you can push back on respectfully to help each other grow and to learn. Collaboration means asking questions as well. Checking in on your group members. That is a part of your responsibility, is to check in on your group members to see if they understand what's going on. If you're stuck, it's on you to ask questions to help each other grow and learn, and ask questions about, well, what is this asking? What am I supposed to be doing here? And again, active collaboration is coming back today. I'm sorry that it's been gone for a while, but it is coming back today because you have got to participate, you've got to collaborate to grow and to learn. What are your questions about the active collaboration before we continue with today? Okay. Here is the scoring rubric. I'm going to go ahead and start passing back the understanding checks from last week. Was it last week or was it Tuesday? Tuesday, thank you. I guess that's yours, you weren't here. So take notes, I'll use your test to reevaluate those skills. Peyton's group, Tori's group, Hudson. Now, I want to remind you, I have the scoring rubric up on the board, but is this the only place that you can find the scoring rubric? Elijah, is that the only place you can find your scoring rubric? No. Okay. Hey guys, focus. Okay. Please remember this, right? This is a scoring rubric, but a better way to say it is a feedback rubric. In general, if you see zeros and ones, what does that tell you? Big picture, looking at the scoring rubric, what does it tell you if you see a 0 or a 1 there?
You did it wrong.
Nope, that is not what it tells you.
Then you either didn't get the correct answer and you justify, or you got the correct answer but didn't justify.
Okay, I like the thoughts, but that's not quite what it tells you.
So
solution response is not valid, but there was at least a justification or the solution response is incorrect, and there was no attempt to justify the response or no attempt to identify.
I mean, you're missing the big picture though.
How about a 0 minus?
I said if you see a 0 or a 1, any 0 or 1, what does that tell you?
Range, like no justification.
You didn't show that you understood.
Okay, you're closer on that. Much closer with that idea. Come on guys, look at the board.
Your level of understanding.
Yes, but look at the board. If you see a 0 or 1 on your paper, what does that tell you about what I saw?
Little or no evidence.
Thank you.
And procedural clues.
Please understand, it's evident, little or no evidence, right? I'm not saying that you don't know how to do it at all, but you need to be aware that if you see a 0 or 1 on your paper, I'm not just saying, hey, this is a bad score. I'm saying, hey, I'm not seeing the evidence that you fully understand. That's the whole point. And that means that either we need to study it better so that we understand it better, or we need to work on our evidence of our understanding. Okay? And so that's again why a 1 plus, right? You have the correct answer, but there's no attempt at justifying, or there are no relevant details in the justification, right? So that still is little or no evidence of your understanding. Okay? The whole point is that if you see a 0 or 1, then that means we need to work on something. Maybe we need to go onto YouTube and watch some videos. Maybe you need to come into tutoring. Maybe you need to get a study group together or something. I want you to be successful, which is why I'm giving you feedback like this. If you see a 2, what does that tell you?
Limited evidence.
Limited evidence of your understanding, right? That's still pretty decent, okay? We want to get out of the 0s to 1s. We want to get at least to those 2s, right? At least partially valid, indicating some understanding, knowledge, a pretty good start, right? We want to do that. And I want to emphasize this because it says it at the top of this understanding check. You can have a completely wrong answer, but can you still show me some evidence of understanding?
Yes.
Yeah. There's no reason to ever leave something blank. Pull on something that you do know. Give me some reasoning for the answer that you put. This is especially true on the back side with number 5. Some of y'all killed me because on number 5, y'all wrote out an equation for 5a, and yet you did not give me any justification. Just tell me why. And then that's still evidence of your understanding. Some evidence. I need you to tell me why. All right, but really where we want to be is at what scores? 3s and 4s. Please hear me very clearly on this, okay? Because I feel like some of us are missing the point. Again, this is this idea of the evidence of your understanding. Is clear evidence of conceptual understanding and or procedural fluency good? Yeah, very good. Okay? You want clear, consistent, and convincing evidence of your understanding, though. But I will point this out. You do not need to see 4 pluses across the board to earn 100 on an understanding check. I convert these, okay, to grades. But what kind of average would you need to see 100?
3s or 4s.
Just a flat 4, not a 4 plus, but a 4, right? If you're showing me clear, consistent, and convincing evidence of your understanding, that's mastery, right? And 100 is mastery of your understanding, okay? So that's the average, but I will point this out. This 3 right here, I believe if you're seeing 3, not 3 pluses, but 3s across the board, you're looking at a low to mid B. I think. I had to go back in and check that. And I will also point this out, that these, when I convert them to grades, are much closer together than these down here, okay? Like this 0, in terms of points, when I put it into the grade book, is a 0. 1 minus is a 1 is a 2, is a value of 2, 1 plus is a value of 3. So there's a lot of change there. But a 2 is 3.5. A 2 plus is a 4, 4.5, 5, 5.5, and 6. So like even though these, it seems like there's a huge variation there, those point values are actually pretty close. And so if you're getting those 3s and above, you're doing well, okay, grade-wise. Show me your evidence of understanding though. You got to remember, it's not just about memorizing math, it's about your understanding. All right, all that. Oh, let's stop before we go here. I forgot to do the bell ringer. view. Stop poll. There we go. All right, looking at it here. 2x cubed minus 16 is dilated by x squared minus 4 to get g of x. How many zeros does g of x have? The most common answer is 2. Can someone who was in the 2 camp tell us why?
There's 2 factors.
Okay, there's 2 factors, right? That's a good point. So what would the equation for g of x be?
Equals x times 2x.
Where's the x coming from?
Hey, what's your question?
What is this g of x? We've got f of x is equal to 2x cubed minus 16, and it's dilated by x squared minus 4.
X squared minus 4 times 2x, whatever, minus 16.
Right? That's my f of x. So there are 2 factors. But I will say the second most common response is 5. Will someone in that camp tell us why they were saying there's 5 zeros? Hudson.
Because if you add the 3 and the 2 to the exponent, that gives you a degree 5. And the degree is most of the time same as the amount of zeros you have. So I put 5.
What do y'all think about that? Anybody want to push back or ask a question about that? We had a lot of people with 2s. No one wants to push back. Kyle?
I'm not pushing back. I was answering. I was asking a question.
Go for it.
How would you exactly know? How would you exactly know, even
Candy, don't put that
if you
in
were
there.
using the exponents and the x-intercept?
Say it one more time. How would you know if you're using the exponents for the
How
x-intercepts?
would you know how many zeros when it has more than like squared, cubed, etc., and still using the roots?
I got you. Hold on to that idea. I'll come back to it in a second, okay? Yes, Tori.
I put 2 because Miss Esther taught us when it's like x's, like the amount of x's in the problem is the degree, the amount of zeros.
Gotcha. I was wondering if that's where some of the misunderstanding came from, so let's talk about this.
So 2 is wrong?
So let's talk about this. How many zeros does this, well, first off, what type of function would just x squared minus 4 be?
That's quadratic.
That's quadratic. How many zeros does a quadratic have? 2. Right? So we already have 2 right there. How many zeros, well, first off, what type of function is that?
That's cubic.
That's cubic. How many zeros does a cubic have?
3.
3. So if we have 2 zeros and then 3 more zeros, how many zeros do we have? 5. Does that make sense?
I put 5 first, but then I changed it.
Okay? And then, but again, I want y'all to remember this, and I need y'all to focus on this. Is it okay to make mistakes? 100,000% yes. We got to grow and we got to learn from those mistakes. The people who are most successful in life are not the ones who get it right the first time. It's the ones who fail and continue to work to master it later.
So you just add those exponents?
So we'll talk about that in just a second, okay? But kind of. So y'all started on lesson 4 yesterday, or not yesterday, recently, at some point. What would I do in order to get the standard form of this polynomial?
What do you multiply the 2 differences you do?
Okay.
Yeah.
So we distribute, right? To get the standard form, I would distribute, wouldn't I? So I would take this x squared and I would multiply it by 2x cubed, which would give me 2x to the 5th. And I'm just going to stop there. So what is the degree of that polynomial?
5.
5. So how many zeros does it have?
5.
So there's 2 things I want you to recognize. One, pay attention to the factors, because the factors can have more than 1 zero. Right? We have 2 zeros in the first factor, 3 zeros in the second factor. Right? But if you put it into standard form, the degree is just the highest exponent. So if you put it into standard form, the degree is just the highest exponent. So you can see it either in factored form or in standard form. Does that make sense so far? Okay? Now we'll go ahead and tell you this. This function, if you graph it, only has 3 x-intercepts.
2 imaginary.
2 of them are imaginary. Great note. Right? It could be that you have a multiplicity. I think y'all started talking about that recently too. So there's a chance that you have multiplicity. You don't. There are 2 imaginary zeros in this one, right? So 3 real zeros, x-intercepts, 2 of them are imaginary. Now, to go back to your question, Kaya, and I think this is going to answer your question, what's another word for a root? Zeros, right? So why do we call them zeros?
Because they have a Y value of 0.
There we go, right? Remember, they're called zeros because x-intercepts have a y value of 0. But remember, x-intercepts are only the real zeros, but we can also have what kind of zeros that we cannot see? Imaginary, right? So we have all those different things going on there. So what property can I now use?
Zero product.
Zero product property. So 0 is equal to x squared minus 4, and 0 is equal to 2x cubed minus 16. What can I now do to find my zeros? Add what?
4.
That's going to create a 0 here. That's good. So 4 is equal to x squared.
When you square root by 2?
Then take the square root by 2, or just square root?
Square root.
Just square root. There we go. All right. So the square root of 4 gives me
2.
anything else?
X equals 2.
Anything else?
X equals plus or negative 2.
Don't forget, when you take a square root,
Next to.
you have to get a positive and a negative, right? That's true anytime you do an even root. If it's an odd root, you don't have to do that. But if it's an even root, you have to do positive and negative, because is 2 squared equal to 4? Yes. Is negative 2 squared equal to 4? So all those things make that equation true. Okay, so notice there's 2 zeros right there. And then when I look here, add 16. So 16 is equal to 2x cubed. I know most of us would want to say divide by 2, but what's the other thing I'd like y'all to think about more?
Times 1
Multiply
half.
by reciprocal.
Multiply by the reciprocal, so times 1/2. Remember, that is 1. What's this?
Divided.
Divided by 2. Okay. So 8 is equal to x cubed. Notice this is not x squared, it's x cubed. Yes, Tori?
Why can't you just divide by 2?
So you can, but it's the inverse operation. So the reciprocal one is known as the multiplicative inverse. And that's an important mathematical idea. But the bigger thing is, actually anyone remember why I like you to think about the reciprocal instead of just division?
You said it's going to help us later.
Something about the sign, ain't it?
So it's not something that's going to help you just later, it's something we've already learned. So right here, what's the pattern? What type of function is this?
Constant multiplicative.
Constant multiplicative, right? Notice it's multiplicative though, not division, right? So you could say that this is division by 3, but if you train yourself to think about that, instead of dividing by 3, what you would want is times 1/3. Because that's going to make your job easier in writing the equation. This is exponential, so y-intercept of 3 times 1/3 raised to the x. So remember, it goes back to the idea of the exponential, and so I'm always trying to teach you all principles that will work in multiple situations, not just one single time. And so training yourself to use the reciprocal here makes identifying the times 1/3 easier to make writing that equation easier. Okay. All right. Notice it's not squared though. What do I need to do to solve this equation? It's not a square root.
Is it just a root?
It is, well, it's a root, but it needs to be a specific root. One thing I'll point out is when we do a square root, it's an understood 2 here in the crook. So the which root?
So it's a cubic root.
A cube root. A third root. Yeah. Whatever is here is the type of root it needs to cancel out the exponent. Anyone know what the cube root of 8 is though?
2.
How do you know that?
Because Ms. Moore taught me last year.
Okay, so why is it 2 though?
I don't know.
Okay, Peyton?
2 times 2 times 2 is 8.
So remember, a cube means that you're repeatedly multiplying it how many times?
3.
3. So a cube root is asking, hey, what was multiplied 3 times? So what was multiplied 3 times to get 8? 2. That's why, right? Remember, we don't want to just memorize things because that will break down eventually, but understanding why, right? A cube means to multiply 3 times, so a cube root is, hey, what was multiplied 3 times to get 8? And it's 2. So I will point this out. I was actually wrong earlier. I didn't realize I did this. Do you know how many x-intercepts we would actually have?
Like,
Look here.
3?
we have 3, right?
2.
Why 2?
2.
Because you only have 2 factors, so that's 0 by property.
2
Because
because there's
there's
just
double
1, 2, and then 1 negative, so 1 positive 2 and 1
So
negative 2.
yeah, notice how that 2 happens twice. So that's only going to be how many x-intercepts?
1.
So it's going to be an x-intercept of 2 comma 0, but it's going to have a multiplicity of 2. And then there's going to be an x-intercept of negative 2 comma 0. And then there's going to be how many imaginary?
3.
1.
Remember, this is a multiplicity of 2. This is a multiplicity of 1. So I've got 3 in my zeros.
That's 2.
So I need 2 more zeros. There are 2 imaginary zeros.
Yeah.
What a recap. Whew. P.S. We will not have an understanding check today, but be ready to take it first thing on Monday. I'm just already looking at time.
Are we done?
You must be outside your mind. 35 minutes into class? An hour and a half class? Come on, you know me. Alright, sorry for that recap. Or for that length of recap. That's not how much I meant to go into it. But what are your questions about the zeros up to this point? And Kai, did that start to answer your question earlier? And so you do have to remember that x-intercepts and zeros and roots are all very related, right? But zeros and roots can have imaginary numbers, but the x-intercepts cannot, right? Zeros can have multiplicities, and so that changes things a little bit about how many x-intercepts we have. I will point this out though. If it's a 5th degree polynomial, it has to have how many zeros when we count the multiplicity? It has to have 5. There's an important term for that, and I'm going to use this regularly. I don't know if Ms. Estel did, because I don't remember if I emphasized it to her. Did Ms. Estel talk about the property that tells us, it's actually a theorem, that tells us a 5th degree polynomial has 5 roots?
It's the algebra property or something like that.
It's the fundamental theorem of algebra. There we go. Be prepared to talk about that on assessments. Be prepared to explain that idea. The fundamental theorem of algebra is literally fundamental to algebra. An nth degree polynomial has n roots. Meaning if you have a 7th degree polynomial, it has 7 roots. Okay? If you have a 15th degree polynomial, it has 15 roots. It's that simple, right? Now it could have multiplicities in there, it could have imaginaries in there, but that's where it is. Alright.
So multiplicity is like if an x is like repeated, like if you had like, you know how you got like 2, like x with the 2's?
Mhm.
So the multiplicity is if a factor or 0 repeats.
Yes. Yes. If a factor of 0 repeats, however many times it repeats, that's its multiplicity. Yep. And that multiplicity counts as the zeros. Because I will remind you, we've already seen it a little bit. Actually, we'll look at it.
So you only
In my-
write down 2, 0 once, but that's 2.
But well, you would write down 2, 0 once,
Yeah,
and then
but
you would
that's
say
two.
with a multiplicity of 2. That's what we call a double root. Yeah. Ladies, did I already lose you?
No.
All right, head up, please. Let's engage. Pay attention. I do love the conversation from some of us, but some of us need to get our hoods down. We need to get involved in the conversation. There we go. All right, so please remember, I've given you an understanding check back, or if we had to miss it, unfortunately, I know sickness has been a rampant issue, which is one of the reasons why I gave a day to work on assignments yesterday. But let's go over this. This is your assessment to write notes on. I didn't provide as much feedback as I normally do, and I'm going to try to do this from now on, because what I want to do is identify issues that I saw on multiple people's assessments and go over those things for you to write down those notes to fix your understanding moving forward. Okay, so number 1. What was a struggle for somebody? All right, so please notice I'm opening the door first for what was a struggle for number 1 so that we can address those things and fix misunderstandings. Gabby.
I don't know where to start.
Okay, didn't know where to start? Does anybody have an idea of where to start? Okay, something with a chart. Okay, I want to break this down though, because this is something that's going to help you on standardized tests. One of the things that I work on with students all the time when I do ACT prep is I focus on an important skill, and that start with the question. There's extra information there, but ultimately, what is the question being asked in this problem? So that's part of a statement, right? Is that a part of the question?
Oh,
So, which statement describes the function?
Okay, and so that's not a great question, but look at your answer choices. When you put the question with those answer choices, what are you supposed to be looking at?
The intercept.
The intercepts, right? That's the starting point. Anybody have an idea now that we can share out about what we're supposed to be looking for if we're trying to look for statements that describe the function h of x that is the product of f of x and g of x, and we're looking at x-intercepts? Gabby?
Y value of 0.
Oh, we might want some y values of zeros, right? We look at those answer choices. And I don't see a whole lot of us writing things down, but this might be a great thing to write down on our understanding check if we miss that. Hey, and please understand me very clearly on this. If you had just underlined x-intercepts and said y equals 0, is that some evidence of your understanding?
Yeah.
That would automatically go from a 0 minus to a 1 minus. Anything else you add after that's extra evidence of your understanding. Show me anything you know. Okay, x-intercepts, so y is equal to 0. Alright? So how are we supposed to find those?
By looking at those.
Okay, so looking at the table, how are we going to find those x-intercepts where y is 0?
Well, you have to look at the x column.
It doesn't f of x or g of x
Yeah.
mean y? Isn't that
So f of x and g of x means y, yeah. Because remember, that's function notation. That's the output when the input is x. Now, Kaya, you said that we need to look at the x column. Now, Gloria, you awake? Stay awake, head up.
Not just the x column, really you have to look at all of them. Well, not say g of x, and the x column and the g of x column to find out if you can find a regular number in the x column and then a 0 in the g of x column to find the x-intercept.
Okay. So what you're saying is that the g of x is our y value, and then we identify the x value that goes with that y value here, okay?
Yeah.
And so if you look at that, then I only see one x-intercept.
No.
Is that correct though?
We gotta look at f of x, so there's a 0 on that one.
There's a 0, so why do we look at the f of x 0 as well?
Because we're trying to find guys functions f of x and g of x.
Close. Well, what function are we actually trying to look at?
H of x,
We're trying to actually look at h of x. And how are we getting h of x?
f of x times g of x.
We're multiplying f of x and g of x, right? Okay. So based on that, does anyone have an answer that they want to share?
I put B.
B has x-intercepts at x equals -1 and 1. Okay, I'm going to show you my solutions in just a second, how I worked it out, but I want to talk about number 2 first, because I put them together, which was silly on my part. But yeah, when we look at that, yeah, we have x-intercepts at x equals -1 and 1, and I'm going to add some more detail on that in a second, so that you can add extra details on your understanding check. Again, guys, I see a whole lot of people with pencils down, not taking any notes about the things we're discussing. You don't just write stuff down that's on the board, you should write down things that you didn't know to improve your understanding. Okay, I cannot emphasize this enough. But I'll put some more up there in a second. Number 2, though, the function f of x is dilated by x to produce g of x equals x times f of x. How many x-intercepts does that function have?
3.
I put 2.
Did you get it right if you put 2?
No.
I put
So-
3.
I hear some people starting to say 3. Can someone give us reasoning for 3?
I put 3 because you have your x plus 5 in one set of parentheses, and your x minus 3 in parentheses. That's 2 x's. And then if you're dilating by x, you're multiplying those 2 x's you already have by another x, and that would be x cubed.
So we would have 3 linear factors, each of those having an x-intercept, so they would have 3 x-intercepts. So here's the answers that I put here. I'm going to talk through a couple more things I want to add in, but this is how I worked them out. Please notice, I went ahead and made a column for h of x. How did I get the values for h of x there?
Multiplying.
I literally just multiplied f of x and g of x because, well, h of x is equal to f of x times g of x, isn't it? Negative 12 times negative 6 is 72. Negative 9 times negative 3 is 27. Ah, notice these x-intercepts that I got right here. Right? Those y values for h of x were 0. And so we have x-intercepts at x equals negative 1 and x equals 1. Zaria, you good with that? You don't need to take any notes at all? Okay. This is another way that you could have approached this, and this is important for what we're going to talk about later. Please note that dilated functions have x-intercepts everywhere the factors have x-intercepts. The factors in this case are f of x and g of x. And so we're looking at those x-intercepts for f of x and g of x. Those would be the x-intercepts for h of x as well. I'm not saying you had to tackle both those methods, but those are 2 different ways you could have talked about the x-intercepts for h of x. Please notice, did I include, I saw some people including this 0, but is that 0 an x-intercept?
That would be a y-intercept, right?
The y-intercept. I would need a y value of 0 somewhere to make that an x-intercept. Now, could you have 0, 0 and it be an x-intercept?
Yeah.
Do we have that?
No.
No.
Yeah, that's where I'm missing it.
Yes, Tori.
Where's the third 0? Yeah, the third 0.
There's not 3. There's just 2.
Wait, so it's, the answer is 2.
Wait, are y'all looking at number 1 or number 2?
Number 2.
Remember, I'm giving the details on number 1 right now. And I'm going to add details on number 2 in a second. I should have split those as 2 different things that showed up, and that was my fault. Well, so look at the notes. Just focus on this right now. We're going to talk a little bit more about 2 in a second. Okay. But notice, Tori, it also has these notes under number 2 right now. Right? Each linear factor has 1, 0, and there are not any repeats. So there are 3 x-intercepts. Negative 5, 0, right? Because x minus r1. 3, 0, x minus r2. And 0, 0 from that x right there. Yeah. This is going to help you later, so I'm going to go ahead and point this out. Remember, g of x is equal to x times f of x. So x plus 5 times x minus 3. That's my f of x. And what do we know about every x-intercept that has ever existed?
Has a y value of 0.
Y value of 0. I point this out because I see a very common mistake for a lot of us. I keep seeing when we have just an x right here that we're saying x equals 1. But remember, what property are we using? 0 product property. So x doesn't equal 1, x is equal to 0 is that first 0. 0 equals x plus 5, which is again how I get x equals negative 5, is that second 0. And 0 is equal to x minus 3. If you follow the idea of x-intercepts at the y is 0 and you stop trying to jump, it will help you significantly. I'm going to wait a second for y'all. Get that written down, see what questions you have.
So when that says like x-intercept and not zeros, that's like telling you it's a real number.
Mm-hmm. That's a good point. Yeah, if it's x-intercepts, it can only be real numbers. Imaginary numbers would not show up on the coordinate system. All right, what are your questions before we continue? All right, that means we should be able to rock and roll on this moving forward. All right, numbers 3 and 4, again, I should have split this up. So we're going to have to talk through both of them first, and then I'll show you my answers for both of them at the same time. A lot of us had a really close idea here, but here's something I wanted to point out, and I think Ms. Essel talked about this, but again, I wasn't in this classroom, so I don't fully know. First off, we want to recognize that we want a volume of what? 50 cubic inches, right? Okay. And so what on this graph is representing volume?
Oh, I just realized that this one.
The y value.
The y values? The curve, right? Please note, I still see a lot of us calling this a line. That is not a line.
That's a cubic.
That's a cubic, or you could just call it a curve, or in general they're called polynomials, right? Any of those would have been fine. Don't call it a line though. Okay, so here's the thing though, right? I want a volume of 50. Most of us recognize, okay, a volume of 50 would be right here. How many times does that line intersect the volume? 3 times. But you don't have 3 dimensions that work.
Why?
Does anybody know why you cannot have all 3? Watch this. First off, can you have negative volume?
No.
So can you have negative heights? No. So none of this would work in the real world. This is part of the volume function, but this doesn't work. So where does the volume function start to work?
In quadrant 1.
Tell me when to stop because it starts working there.
Stop.
That's where y is equal to 50.
Or is that
I'm just asking, where does the volume function work? At 0, 0. Tell me when to stop because the volume function will no longer work.
Stop. Below the exact.
That is the only domain that actually works for the volume function. So even though this point right here, that 9.39, is intersecting the volume function, that does not work. Only these two work for the domain of the planter box.
Wait, why
So
don't is it because it goes below the
Cannot have negative,
oh, okay.
so it can't have negative volume. And so anything that's past that will not work, right? Anything that goes past that negative volume won't work as well. Okay? So that would be the issue there.
Hey, what is the D on the understanding check again?
Details.
Details. You're missing important details for explaining it thoroughly to demonstrate understanding. And so like the reason why that D is really important is because you may have a misunderstanding and I can't give you any feedback on it because I don't see the information there. That would reveal that misunderstanding, and so I can't say that you have a complete understanding because I don't see the evidence. So that's where you want to improve your understanding or improve the evidence you're giving. Okay? Alright.
How would you get a 3 on that?
A 3?
I don't know this. I mean, I thought about it. I just didn't explain it.
Well,
no, yeah.
right. I mean, like this right here, I'd have to think about it. This would either be a 3 or a 3 plus this amount of information. Probably a 3. It's not quite a 3 plus. It's not a complete level of understanding. I would want more than just circling these points to explain that. I'll show you what I put in a second. But let's talk about number 4 first, and then I'll show you my answers that I did for this. Number 4, which graph could represent a function with roots at x equals -1, x equals 3, and x equals -5? First off, which of these can we quickly eliminate?
The third one.
The third one, because that's what type of function? Quadratic, and it only has two x-intercepts. And remember, those x-intercepts go with roots. Gabby, did you want to answer that or answer something else?
I have a question about 3.
Okay, what's your question about 3?
I couldn't dig one.
So remember right here, we can't have negative volume. And so anything past this x-intercept will not work. Right? So like you can only in the so remember, even though this comes back to being positive, you can't go past here in the first place. I don't know if Miss Essel got a chance to explain this because I wasn't clear, but the whole idea with a planter box is that we're going to cut out the corners here.
She did.
Did she actually cut it out like this?
Yeah, she did.
Okay. So when you cut it out like this, you're going to get those corners and you're going to fold it up. And there's one side of that planter box, right? And then you fold up the other sides as well. However, what happens when you get halfway through and you cut that out, right? So I cut out half on this side and I cut out half on this side. Do I have anything that I can fold up? No. Because I don't have anything that I can fold up, the volume would be 0. Well, anything beyond that 0 wouldn't work, right? So I can't go past that 0 right there. Does that explain it? Yeah. So anything past it, even though it starts to be positive, won't work. Good question. Okay. Yeah, so this third one is out. There's only 2 x-intercepts, right? 2 roots there. It's quadratic, not cubic. I want y'all to be careful. I saw a lot of us say that there's actually only 1 x-intercept here, but if you look closely, there's just 2 x-intercepts that are really close. I know that because the curve dips below the x-axis. So be aware of that. The other thing I want to point out is this. I saw a lot of us draw numbers in on the x-axis to kind of approximate things. And that's okay, but are there any numbers actually on those axes right now? No. So you don't actually know the scale. You can't make that statement of where those x values are. And I will say that there are 2 answers, depending on how you justified it, that are possibilities, but there's only 1 actual correct answer in this one. Which are the 2 that are possibilities?
First and the last.
So what's the first and last, the left and right, like what's there that tells us they're possibilities?
On the first one to the left, there's 2 roots to the left of the y, so check some negative.
Okay, so we have 2 negative roots and
1 positive.
and 1 positive, and over here,
You have 2 negatives, 1 positive.
2 negatives and 1 positive. But does anyone know what the issue with this one is? A lot of us put this answer, which is close, but we did not justify, so I could not give you credit. What's the issue with this one?
It's a little too far.
Yeah, I was just about to say that.
What's the issue with that positive? It's too far to the right. The positive is only a 3, right? Can 3 be further to the right than negative 5? No. So great note on that, AJ, right? Like, that's what I would want y'all to notice and pay attention to. We need to think logically about those things, right? So yeah, 1 negative, 2 positive. I probably should have put more detail on that. I said 2 negative roots, 1 positive. This, I'll go ahead and tell you, this would not be a 4 plus for sure. I don't even know if this would be a 4. This might be a 3 plus. I very clearly explained why it can't be these 3. I should have done a better job on explaining why it is 4. But notice how I talked about that positive root is further from 0 than this negative root, but that's not true, right, for negative 5 and 3, right? So I talked about how that's not quite true there. And Gabby, notice right here, something that y'all talked about, this from lesson 3, something y'all should have talked about in lesson 3 is the domain. Notice the domain is only from 0 to 6. Those are the actual only x values that work, right? So the domain is only from 0 to 6. And so because the domain is 0 to 6, you can't have that 9.39 for the height.
Wait, so you put brackets around your domain instead of like parentheses like a point? Is that how you like differentiate the 2?
That's a good question. Did y'all talk about interval notation with Miss Estel?
No.
No. So we'll talk about that more next unit. So you could have just said the domain is from 0 to 6 inches or something like that. It honestly depends. If it's a number or a value that can be equaled or included, you use a bracket. If it's a number that cannot be equaled or included, you use a parentheses. So like if I were to look at not the volume for the real world, but this whole thing, does this ever quit going to the left? So then the lowest x value would be negative infinity. Can you ever equal negative infinity? So you would put a parenthesis on that, right? And then it never quits going to the right for the overall polynomial, so the max x value would be infinity, and again, you can't equal it, right? So if you can equal or include that number, and again, I'm not assessing on that, I'm just answering Hudson's question. If it can be equaled, bracket. If it cannot be equaled, parenthesis, and we'll do more of that next unit. Because I think in Mathia, they actually only had you do like inequalities, right? X is greater than 3, or all real numbers, things like that, and so we'll apply that as well. All right, what are your questions before we continue on to the back side here? Going once, going twice. Sold. All right. Is this the question that Ms. Essel went over with y'all on Wednesday, or was it the other? This one? Okay, so I'm just going to show my answers. I know that she talked about this one already. Here are my answers. I'm going to talk about one other option in a second. This is a lot of detail. You don't have enough time to write all this down because we need to get to wrapping up lesson 4. The big things I want to point out is this, and this is something that a lot of y'all made harder than it had to be. What are those 3 blue lines there?
They're negative.
Your linear factors.
Those are just the linear factors. To get the polynomial, graph your factors. And I'm going to show it with using the quadratic that you started with in a second, because some of us did use that. But I want to point out that I just drew the 3 linear factors, and be careful. What is the slope of every one of those linear factors? 1. Yes, Madison.
Mr. Kenny, how did you get 0 for a 0?
What?
How did you get, x equals 0?
So first off, did you write this dilated function g of x equals x times f of x?
Yeah.
Did you then write x times x plus 4 times x plus 2?
No.
Okay, well that's the dilated function, right?
Yeah.
Okay. And what do we know about every 0 that the y value is?
0.
So I set 0 equal to that, right? So let me write it a little bit bigger. 0 is equal to x times x plus 4 times x plus 2. Madison, what is the really important property that I can use right here?
Distribution.
That to help me get standard form.
Oh.
Y'all hadn't learned that yet.
0 product property?
Can we use zero product property here? And so what does the zero product property tell us? Anybody?
That at least one of the factors equals 0.
At least one of the factors equals 0. To multiply 3 things and get 0, at least one of those factors has to equal 0. So, and a lot of y'all are writing x equals 1 here, but that's not what it says. This is the factor x. And what does that factor have to equal?
0.
0. That's the whole thing of the zero product property, is that each factor is set then equal to 0. Does that answer your question, Madison?
How are we getting 1? How do you know I got 1?
Because a whole lot of you made that mistake, which is why I actually talked about it already today.
I know, but yeah, I put 1 too.
Right, because you see 1x, and so you say x equals 1. But that's not it. That's why we need to understand that zero product property, that factor is equal to 0. To get x equals 1, I would have actually needed x minus 1 there, because then 0 would equal x minus 1. I would add my 1, and then 1 is equal to x. Right? I don't have an x minus 1. I just had an x. Does that explain? And also, the other thing, Madison, please hear me very clearly on this. I've seen students make that mistake year after year after year. It's not just you. That's why I talked about it earlier. That's something I would have addressed more heavily if I'd been here to teach y'all that over the last 2 weeks. And I apologize for that.
You're a kid. Why are you saying sorry?
Because I have to balance responsibilities. Like, I'm glad I was at home with my child, but at the same time, like, that doesn't mean that I don't feel bad about not being here to teach. Thanks, Olivia. All right. So please note again, I graphed each of those linear factors and I used those linear factors to determine if the polynomial was positive or negative. I saw a lot of us touch the x-axis and then bounce away. I'm going to talk about that later because that's only going to happen sometimes. And you can't see it, but I drew vertical lines